Okay, we're looking at something called linked reconciliations. Now this is where we take two different scenarios, two different reconciliations, and put them together and see if we can solve a problem. Okay, so let's just go for this one. It says Cool Car Rental has an office at Glasgow Airport and one at Edinburgh Airport. The total number of cars that are stored at both depots is 100. Okay, so that's the total number of cars. Experience has shown that 85% of the cars rented at Glasgow are returned to Glasgow, while the remainder are returned to Edinburgh. Of the cars rented at Edinburgh, 55% are returned there, while the remaining 45% go back to Glasgow Airport. What is the optimum number of cars based at each airport? The first thing that I would say is optimum seems to suggest that we're going to investigate some kind of limit. So let's just think about what we've got again, right? So we've got this car rental company has got an office at Glasgow and obviously at Edinburgh Airport. So obviously you can hire cars from either Glasgow or Edinburgh Airport here. In total we've got 100 cars. So the cars that are hired at Glasgow Airport, 85% go back to Glasgow, the remainder go to Edinburgh. Cars hired at Edinburgh Airport, 55% go back to Edinburgh and the other 45% go back to Glasgow. Okay, the first thing that we could say to get going then is, let's say that GN is number of cars in Glasgow and EN is number of cars in Edinburgh. Well, what we could say then, fairly obviously, is the number of cars in Edinburgh and Glasgow altogether is 100. So GN plus EN equals 100. So that's just as simple as cars in Glasgow plus cars in Edinburgh is the total number of cars, that is 100. Okay, so what I'm going to now do is set up a reconciliation for Glasgow Airport. So next week, that would be GN plus 1. What I know is that 85% of the cars rented at Glasgow go back to Glasgow. Okay, so from last week, that would be GN. So GN is number of cars last week in Glasgow. 85% go back to Glasgow next week. So that's 0.85 GN. Now, as well as the 85% of cars rented at Glasgow coming back to Glasgow, which is a 0.85 GN, also get some cars from Edinburgh Airport as well. So of the cars rented at Edinburgh, 55% go back to Edinburgh, which means 45% come to Glasgow. So that means I also get 45% of last week's Edinburgh cars. So let's just go over that again. So this week, GN plus 1, of the cars rented at Glasgow, 85% will come back, so that's 0.85 GN. But I'll also get 45% of the cars that were rented at Edinburgh coming to Glasgow, and that's detailed just a bit here in the question. Okay. Now the next thing that I want to do is to rewrite this reconciliation so that it doesn't have GN and EN in it. Now I can do that using this equation here. So what I can see is that GN plus EN equals 100. Now, what I could do then is change the subject of the formula there, and that would be EN equals 100 minus GN. Now what I can do now is make a substitution. Where I see EN, I could replace it with 100 minus GN. So it's going to be GN plus 1 equals 0.85 GN plus 0.45 lots of EN, and EN is 100 minus GN. I can now open that up. 0.85 GN plus 0.45 times 100 is 45, and then 0.45 times minus GN is minus 0.45 GN. I can now tidy the thing up. 0.85 GN minus 0.45 GN is 0.4 GN, and I've still got my plus 45. Okay, what I can do now is calculate the limit. So how do we do that again? Well, at some point the number of cars will reach its limit. and then next week you'll get the limit again, so that's the optimum number of cars. So at some point we reach the limit, and then next week you've got the limit again. And that only makes sense because if you reach the limit, by implication you'll continue to get the limit because that's what you've reached. Then bring that over, and that's L minus 0.4L equals 45. 0.6L equals 45. L equals 45 divided by 0.6. Multiply top and bottom by 10 there. And that'll give me 450 divided by 6. 400 divided by 6, 50 divided by 6, and that'll give me 75. Okay, so what's that limit for? That's the limit for Glasgow cars. So the optimum number of cars at Glasgow is 75, and in Edinburgh, that's dead easy because if there's 100 cars altogether and 75 are going to Glasgow, then 25 must be going to Edinburgh, and in Edinburgh is 25 cars. Okay, that's the question done. Let's just go over it in a bit of detail again. Okay, first thing, let's come up with an equation to state what we've got in total. We've got all the Glasgow cars and all the Edinburgh cars is 100. Okay, then what I've did is I've went after a reconciliation for cars at Glasgow next week. So what does that compose of? Well, 85% of the cars rented at Glasgow go back there next week. Okay, so of the Glasgow cars, 85% go back to Glasgow next week. But on top of that, of the cars rented at Edinburgh, 55% go back to Edinburgh, but 45% go to Glasgow. So you're also getting back to Glasgow 45% of the Edinburgh cars. So that is 45% of last week's Edinburgh cars. So the reconciliation then is next week in Glasgow, I'll get 85% of the Glasgow cars back, but I'll also get 45% of the Edinburgh cars coming to Glasgow. Gn plus 1 equals 0.85, Gn plus 0.45 En. I can then take this equation, Gn plus En equals 100, bring that across, and you've now got En equals 100 minus Gn. And now what I can do is where I see En, I can sub in 100 minus Gn, which is what I've did there. Open it up, click things together, and you get your reconciliation, and then investigate the limit. Let's try a second example. Okay, let's try another one which is similar. Okay, Central Scotland Car Hire have a depot at Glasgow Airport and one at Edinburgh. Total number of cars is 150. Experience has shown that 70% of the cars hired at Glasgow go back to Glasgow. The remainder go to Edinburgh. Of the cars hired at Edinburgh, 60% go back to Edinburgh and the rest go to Glasgow. What's the optimum number of cars? Right, just very similar example, but slightly different numbers, which is ideal. So let's just get into this one. Okay, so let's focus on what's happening next week in Glasgow, Gn plus 1. Okay, so Glasgow will get 70% of the cars going back to Glasgow. Experience has shown that 70% of the cars hired at Glasgow get back to Glasgow. Okay, so that's 0.7 Gn. Now, it also gets some of the Edinburgh cars. 60% of Edinburgh cars go back to Edinburgh, which obviously means that Glasgow gets 40% of the Edinburgh cars. Okay, now what I should have did to get going was to put down a simple equation, which is Glasgow cars plus Edinburgh cars equals 150. Okay, now what I can do now is make a substitution for that En, bring that over again. En equals 150 minus Gn. So that's 0.7 Gn plus 0.4 lots of En, which is 150 minus Gn. gn plus 1 equals 0.7 gn. 0.4 times 150, take your time, that's 60, minus 0.4 gn. 0.7 gn minus 0.4 gn is 0.3 gn plus 60. Okay, now optimum is telling me again to investigate the limit, so at some point we reach the limit, and then next week you'll be at the limit again. Bring that over, L minus 0.3 L equals 60. L take away 0.3 L is 0.7 L equals 60. L equals 60 over 0.7, multiply top and bottom by 10, and I'll get 600 divided by 7. Okay, now that gives me a kind of awkward result, 85.7. I think we just round that to 86 cars. Okay, so 86 cars in Glasgow Airport. If there's 150 cars in total, take 86 off 150, and that will give me 64 cars at Edinburgh Airport. Okay, you're going to try this one. You've got two libraries, A and B, have 100 books in total. So number of books in A plus number of books in B is 100. Okay, so it's just a step for a hint to get going. Every week, 85% of the books borrowed from Library A go back to Library A. The remainder go to Library B. Only 55% of the books borrowed from Library B return there, which obviously implies that 45% will go to Library A. Find out what happens in the long run. Right, that's asking you to investigate the limit. So to get going, I would start with trying to set up a reconciliation for books in Library A next week. Now, it's a slightly different context to the first two questions, which were cars at an airport, but basically the same question with different numbers. Have a go and we'll pick that up tomorrow, as well as the daily hire homework 7.